calculus from Wallis to Newton to Leibniz. 17th century, Wallis was among a few mathematicians to discuss the idea of derivative. In his 1656 work, his most important work was published, and he started by developing the standard of notation for power and extending them to positive rational numbers. So, for example, x to the 0 is 1, x to the negative 1 is 1 divided by x. He talked about the power of 1/2 and 2/3, so he created that. Or extended that, not created. Another accomplishment of Wallis was he provided that the ratio of the area of an enclosed curve to the area of a parallelogram on the same base. And he did that by extending Cavalera's quadratic formula. And these are some of the formulas that he used. You have the summation, you have the integral. Wallis is also known for the principle of interpolation. The ordinates of the circle is the geometric mean of the ordinates of the curve. By approximation, the area of the semicircle could be taken as the geometric mean value of, and again, there are some formulas down there. Y equals the square root of 1 minus x squared. Y could be this, y could be that, and then it could be the integral of both of those. Newton provided integral calculus, especially within physics applications. Leibniz worked with developing consistency, useful notations, and concepts. Both are credited with making discoveries in the area of infinitesimalis. Newton wrote his discoveries in letters and smaller papers. He extended the binomial theorem to include fractional and negative numbers. He was able to talk about the infinite series, and he determined the area of the curve by calculating the rate of change and extrapolating the total area. He's responsible for present-day derivative, and he was known for applying math to the physical world. Leibniz had some discoveries in a manuscript of various notations. He is known for the d of x and d of y, for the increments of abacus and ordinates, and he also began the present-day integral formula.